Almost 2 years ago, one of my friends purchased a portable monitor to use for his PC setup. It was a pretty nice monitor for its price, but it had one flaw. The monitor stand wasn't the best. Within 48 hours of having the screen, I was over it and I began brainstorming ideas for a new stand design. I wanted a base clamp design that would support the load of other components as well as the Lepow screen while remaining structurally sound. The results of the first base clamp design were not what I was expecting, and I had no faith in the design's ability to stand the test of time. I took some time out to do some brainstorming to come up with solutions to the issues discovered in the first base clamp design. Several weeks later, I was back to the drawing board with a fresh mind and newer ideas. The final design was a success. The clamp worked perfectly and it was securely clamped to my desk with no signs of failure. It was now time to continue with the rest of my design. The wrist and mount components were too heavy to keep the forearm up in a 45-degree position, so I knew for a fact the forearm would not be able to hold this position with the Lepow screen as well. So my concept didn't work out. Even after all the components printed out and were assembled smoothly, catastrophe still managed to strike again, and right before the finish line. I took some time out again to think of a solution for the new challenge I was faced with. Even though my spring concept didn't work, the rest of the components functioned properly. I was so close. There had to be a solution to the issue, and I came too far to give up. I remember when I first went to the McMaster-Carr site to find a spring to use as a tensioner. I noticed a wide variety of gas springs that I just knew would work well for my design, if only I were working with metal components. I thought the gas spring would be too strong to be effective in my design, and I didn't believe the plastic 3D printed components would be solid enough to work with the gas spring, so I bypassed the idea. But now that I was stuck with a failed concept and a project that was 90% complete, I figured I'd take a chance. I had nothing to lose, and I knew I wouldn't know for sure unless I tried. I went through every type of gas spring available, and even gave McMaster-Carr a call, and their customer service was very helpful. When I found the right length gas spring, I chose the weakest one available with a 15-pound extension force and a 20-pound compression force, which meant that it would take 20 pounds or greater to close the cylinder of the gas spring. Now I knew for a fact that the mount assembly and Lepow screen wasn't even close to 20 pounds fully assembled. So I knew the gas spring would be able to hold the components up in a 45-degree position. But would the components be strong enough not to crack under the force of the gas spring pushing back while the cylinder was being closed? There was only one way to find out. I went back into my design to delete the initial design features of the elbow and wrist. These were the only two components that connected to the original spring. After that, I downloaded the gas spring and uploaded it into my design, and began making design changes to the elbow and wrist to mate with the new gas spring component. I designed triangular slots on the wrist and elbow for the gas spring eyelets to slide between, and I created 0.20 inch diameter through holes where the eyelets will line up to connect to the wrist on one end and the elbow on the other end. I had to continuously adjust the forearm length to mate with the gas spring while it was fully extended in the up position of the forearm. Since the gas spring uses two eyelet connections on both ends, which were sold separately by the way, I had to add 2 more binding barrels to my design to support the gas spring. Here's how the new concept works. When the forearm is parallel to the desk, the distance between the center points of the through holes on the elbow and wrist is 6.41 inches. But when the forearm is adjusted up or down 45 degrees, the distance between the center points is 6.91 inches. Now, the total length of the gas spring when it is fully extended is also 6.91 inches. So when the forearm is up in the 45-degree position, the forearm should stay up because the weight of the Lepow screen, wrist, and mount components are not greater than 20 pounds, which is the compression force of the gas spring. And since the distance between the through holes on the elbow and wrist is shorter by ½ an inch while the forearm is parallel to the ground, the gas spring will naturally want to extend either up or down 45 degrees to reach its max extension. So since the gas spring is naturally pushing outward with a force of 15 pounds, No matter which position the forearm is in, it should be able to hold that position without a problem. Keeping the forearm in the downward position is easy. We saw that in the last concept. It's getting the forearm to stay in the up position. That's the challenge. I hope this new concept explanation makes more sense to the viewers than the first one. Once I had the gas spring integrated into my CAD design, I placed an order for the new spring and other pieces of hardware I needed for the new concept. In the meantime, while waiting for my order, I began 3D printing the new and hopefully final elbow, forearm, and wrist components. Thankfully, my order came in much sooner than I was expecting, so I assembled the hardware and slowly began assembling the components as they finished printing. After 96 hours, all of the components were printed out and assembled, and here were the results.
Yo, it's finally fixed. I made the change. Check it out. You dig? Lift this motherfucker up. You dig? That motherfucker stay up now. You dig? Had to get rid of that spring. Put a little gas spring off in there. You see what I'm saying? You see the little action we got going on in here? So we ready to go now. We ready to go. Hold on, let me let it down. You gotta do it with 2 hands. Boom. We ready to go.
The new concept worked out exactly how I was hoping it would, and my new mount design was a success. After all the trials and tribulations, I finally had a new screen mount design that conveniently held the Lepow screen at eye level and could easily be rotated and adjusted. Now I know some of you are saying, enough with all the 3D modeling and technical talk, let's see an installation video. Well, good, because I was thinking the exact same thing. Installation begins with the assembly of the subassemblies. There are 3 of them. The base subassembly, the forearm subassembly, and the mount subassembly. The base subassembly has 7 components: the fixed jaw, the lower frame, the adjustable screw, the handle for the adjustable screw, the movable jaw, the lock pin, and the lower shaft component. These components are assembled using 6 1¼ inch long 1/4 inch by 20 round head screws, 6 1/4 inch by 20 nuts, 3 1/4 inch washers, 1 8/32 nut, and 1 2 inch long 8/32 round head screw. First, I connect the lower shaft component to the fixed jaw by aligning the 3 holes at the top of the fixed jaw with the 3 holes at the bottom of the lower shaft. The lower shaft has 3 slots near the bottom where the first 3 1/4 inch by 20 nuts are inserted to mate with the first 3 1/4 inch by 20 round head screws. Once the holes of the shaft and fixed jaw are aligned, I insert the 3 1/4 inch by 20 screws and fasten them in with a standard Phillips screwdriver. There are 3 slots with 1/4 inch diameter through holes on the outside face of the fixed jaw for the 3 remaining 1/4 inch by 20 nuts. I place the 3 nuts in these slots and sit the base off to the side. I grab the lower frame and I place 3 washers in the 3 counterbore holes on the front face of the lower frame. The counterbore holes also have 1/4 inch diameter through holes for screws to be inserted. After placing the washers, I align the 3 lower frame through holes with the 3 through holes of the inside face of the fixed jaw. I then insert the remaining 1/4 inch by 20 round head screws and I fasten them in place with the screwdriver. After that, I sit the base to the side once again. Next, I assemble the handle and adjustable screw. The handle has a single slot for the 1 8/32 nut and a 0.20 inch diameter through hole that goes through the neck of the handle. Once the nut is in place, I insert the adjustable screw to the handle and connect both components using the screwdriver to fasten the 2 inch long 8/32 round head screw. The 2 inch long screw goes through both the handle and adjustable screw, so when tightened, these components are firmly connected. FYI, ignore the extra nuts still laying on the table. They weren't actually used because the lower shaft had the 3 nuts pre-installed already and they could not be removed. Anyway, it's now time to insert the adjustable screw to the lower frame. But before doing so, I had to add my lubricant, the Vaseline. I placed a little on both sides of the adjustable screw and I carefully screwed it into the lower frame, just enough to add the final component, the movable jaw. The movable jaw has a nice press fit connection thanks to the ball joint design, so it's pretty simple to snap it into place. The lock pin will be inserted later once the base is fixed to the desk. You'll see how in a bit. The base subassembly is now complete. Now, let's move on to the next subassembly, the forearm. The forearm subassembly has 4 components: the elbow, the upper and lower bridges, the wrist, and the gas spring. These components are assembled using 4 2-inch long binding barrels with corresponding screws and 2 3/4 inch long binding barrels with corresponding screws. First, I remove the corresponding screw from one of the 2-inch long binding barrels and I connect the upper bridge to the elbow. I insert the binding barrel through the 1/4 inch diameter through hole of the forearm bridge and the 1/4 inch diameter through hole of the elbow. Once the binding barrel is in place, I screw in the corresponding screw using the standard Phillips screwdriver. I follow these same steps for the lower forearm bridge. Keep in mind that the forearm bridges are identical, so I technically could have started with either one of them. Once the bridges are in place, I unscrewed the corresponding screw from one of the 3/4 inch long binding barrel screws. I grabbed the gas spring with the eyelets already screwed in place and I connected it to the triangular slot of the elbow. I inserted the 3/4 inch binding barrel screw and I fastened down its corresponding screw with the screwdriver. Now that I had the bridges and gas spring connected to the elbow, I connected the wrist to the assembly, but in reverse. I connected the opposite end of the gas spring to the triangular slot of the wrist first, and I fastened it in place with the last 3/4 inch binding barrel screw. After that, I connect the upper bridge to the wrist and then the lower bridge to the wrist using the other 2-inch long binding barrel screws. After a few test movements, the forearm subassembly is now complete. Last but not least, let's finish up the subassemblies with the mount subassembly. The mount subassembly has 3 components: the midsection, the upper jaw, and the lower jaw. These components are assembled using 4 1/2 inch long 8/32 round head screws and 4 8/32 nuts. There are 4 slots at the back of the midsection for the 4 8/32 nuts to be inserted, but I already placed nuts in these slots and they cannot be removed, so I won't actually be using the nuts you see here. After the nuts are in place, I flip the midsection around and I align the lower jaw with 0.20 inch diameter holes at the bottom of the midsection. Then I insert 8/32 round head screws through the holes on both sides of the lower jaw. The screws mate with the pre-inserted nuts of the midsection internally. After the lower jaw is in place, I follow the same steps to assemble the upper jaw. And voila, the mount subassembly is now complete. Now that the subassemblies are complete, we can begin installation. For the installation, we have the base subassembly, the lock pin, the shaft separator, the upper shaft, the shoulder, the bicep, the forearm subassembly, and the mount subassembly. These components and subassemblies are fastened together using 1 3/4 inch long 1/4 inch by 20 round head screw, 1 1/4 inch by 20 nut, 1 1/4 inch washer, and 3 3-inch long 1/4 inch by 20 round head screws with 3 1/4 inch by 20 nylon lock nuts. First, I clamp down the base subassembly to the desk. As I hold the base firmly to the desk, I turn the handle until the slots for the lock pin are aligned and the clamp is fully tightened to the desk. After tightening down the base, I insert the lock pin to lock it in place. And again, the lock pin may be overkill for my design, but I like it, so let's roll with it. Next, I screw the shaft separator to the lower shaft. Then I screw the upper shaft to the other end of the shaft separator. The next component to assemble is the shoulder, but before I continue, I want to point out the slot at the top of the upper shaft. This slot is for a 1/4 inch by 20 nut to be inserted. The nut aligns with a 0.20 inch diameter hole that runs from the slot to the top of the upper shaft. The nut will mate with a 3/4 inch long 1/4 inch by 20 round head screw that will go through the top of the shoulder to connect the shoulder to the upper shaft. But before placing the shoulder onto the upper shaft, I'll place a 1/4" washer into a counterbore hole on the top of the shoulder to improve the connection between the upper shaft and the shoulder. Once the shoulder is fastened in place, I grab the bicep and one of the 3" long 1/4" by 20 round head screws, and I place the screw through one end of the bicep. When the screw is fully inserted through the bicep, I place the bicep onto the protruded area of the shoulder, inserting the screw through another hole on the protruded area of the shoulder. Now that the bicep is in place, I tighten the nylon lock nut to the end of the screw using a socket wrench, connecting the bicep to the shoulder. I do the same thing to connect the forearm subassembly to the other end of the bicep. By placing another 3" long 1/4" by 20 round head screw through the elbow of the forearm subassembly, I connect the assembly to the bicep again using a nylon lock nut, and I fasten them down using the socket wrench. Finally, I connect the mount subassembly to the forearm subassembly by inserting the last 3" long 1/4" by 20 round head screw through the wrist of the forearm subassembly and the back of the mount midsection, fastening them down with the last nylon lock nut. To put the icing on the cake, I carefully insert the Lepow screen through the jaws of the mount subassembly. The installation is now complete. Well, there you have it. Another problem solved, another project complete. I hope you guys enjoyed this video. Be sure to like, share, subscribe, and be on the lookout for more content to come. Thanks for watching.